Hi everyone! Today we're going to study Caesar cipher. Cryptography is the study of methods for sending secret messages. It involves encryption, in which a message, called plain text, is converted into a form called ciphertext that may be sent over channels possibly open to view by outside parties. The receiver of the ciphertext uses decryption to convert the ciphertext back into plain text. Let us now study Caesar cipher. One of the earliest known uses of cryptography was done by Julius Caesar. He made messages secret by shifting each letter 3 letters forward in the alphabet. For instance, the letter A is sent to D and the letter Y is sent to B. To express Caesar's encryption process mathematically, first replace each letter by an element of Z sub 26, that is, an integer from 0 to 25. We replace A by 0, B by 1, K by 10, and Z by 25. So this will be our alphanumeric table. Caesar's encryption method can be represented by the function f of p is equal to the quantity p plus 3 mod 26. We see here that p is less than or equal to 25. In the encrypted version of the message, the letter represented by p is replaced with a letter represented by p plus 3, then mod 26. To recover the original message from a secret message encrypted by the Caesar cipher, the function f inverse, so this is the inverse of f, is used. Note that the function f raised to negative 1, or the f inverse, sends an integer c from z sub 26. This is the f inverse of c is equal to the quantity c minus 3 mod 26. In other words, to find the original message, each letter is shifted back 3 letters in the alphabet. Note that first 3 letters is sent to the last 3 letters of the alphabet. Let us see example 1. Use the Caesar cipher to encrypt the message, "How are you?" Step 1. We translate each letter to the corresponding element of Z sub 26. We have this alphanumeric table above. Then we write the message "How are you?" down here. For each letter, we will write the corresponding number based on this table. H is 7, O 14, W 22, and so on. Now for step 2, we replace each of these numbers p by f of p is equal to p plus 3, then mod 26. Meaning for this number 7, we're going to have 7 plus 3. It becomes 10. And that 10 mod 26 is simply 10. So it will be like this. The 7 becomes 10. The 14 is now 14 plus 3 becomes 17. 17 mod 26 is 17. 22 plus 3 is 25. 25 mod 26 is 25. For the 0 plus 3 is 3. 3 mod 26 is 3. Now, we are doing same pattern for the other numbers. With regard to 24, we have now 24 plus 3, that is 27. 27 mod 26, and that will be 27 divided by 26, and the remainder is 1. So we write here 1. For step 3, we translate this back to letters to get the encrypted message. Using the same table above, we will write the corresponding letters based on the numbers, meaning this 10 becomes K, 17 is R, 25 is Z, and so on. This is now the final answer. Example 2. Use the Caesar cipher to decrypt the message capital L space capital D capital P space capital I capital L capital Q capital H. For step 1, we will translate each letter to the corresponding element of Z sub 26. So we have our alphanumeric table above here. For the message above, the numbers corresponding are here. L is 11, D is 3, P 15, I is 8, L 11, Q 16, H is 7. Then step 2, we decrypt the message using the F inverse of C is equal to the quantity C minus 3, then mod 26. So we subtract 3 for 11, that is 8, and 8 mod 26 is 8. 3 minus 3 is 0, 0 mod 26 is 0. 15 minus 3 is 12, 12 mod 26 is 12. 8 minus 3 is 5, 5 mod 26 is 5. 11 minus 3 is 8, 8 mod 26 is 8. 16 minus 3 is 13, 13 mod 26 is 13. 7 minus 3 is 4, 4 mod 26 is 4. Then, step 3, we translate back to letters to get the decrypted message. So the letter corresponding to 8 is I, 0 is A, 12 is M, 5 is F, 8 is I, 13 is N, 4 is E. So the message is I am fine. Today we're going to study shift cipher. There are various ways to generalize the Caesar cipher. For example, instead of shifting the numerical equivalent of each letter by 3, we can shift the numerical equivalent of each letter by k, so that the function f of p is equal to the quantity p plus k, then mod 26. Here, the integer k is called a key. Such a cipher is called a shift cipher. Note that decryption can be carried out using the F inverse of C, that is equal to C minus K mod 26. Example 1. Encrypt the message stop pollution by applying the encryption function f of p equals the quantity p plus 21 mod 26. For step 1, we're going to translate each letter to the corresponding element of Z sub 26. Let us show our alphanumeric table. We know that A starts with 0, B corresponds to 1, C corresponds to 2, so on and so forth, and the Z corresponds to 25. So we write the message stop pollution here, and then we're going to write the corresponding numbers for the letters. The S is 18, T is 19, O 14, P 15, O 14, L 11, U 20, T 19, I 8, O 14, N 13. Then step 2, we will replace each of these numbers P by f of P is equal to the quantity P plus 21 mod 26. Let's begin with the first number, 18. So we are going to have 18 plus 21. The answer is 39. Then we take the mod 26. The answer here is 13. So for number 18, the value is 13. We're going to use this pattern for all the remaining numbers. It means the 19 becomes 14, 14 is 9, 15 is 10, 14 is 9, 11 is 6, 20 is 15, 19 is 14, 8 becomes 3, 14 is 9, 13 becomes 8. Now for step 3, we translate this back to letters to get the encrypted message. We will use the same table in here. The 13 number becomes N, 14 is O, 9 is J, 10 is K, 10 is K, 9 is J, 6 is G, 6 another G, 15 is P, 14 is O, 3 is D, 9 is J, 8 is I. This is the final answer. Example 2. Decrypt the message encrypted using the shift cipher. F of P equals the quantity P plus 10 mod 26. The message is C E B B O X N O B space X Y G. Step 1. We translate each letter to the corresponding element of Z sub 26. Here is our table. So for the message, we write it here, and the numbers corresponding to each of the letters are here. C is 2, E is 4, B is 1, B is 1, O 14, X 23, N 13, O 14, B 1. Then X 23, Y 24, G 6. For step 2, we're going to decrypt the message using the F inverse function C is equal to the quantity C minus 10. Take note that our function given here is f of P equals P plus 10. The key is the number 10. So in our F inverse, we're going to use the same value P, but this time it is C minus 10. Then mod 26. Let's begin with the number 2. So we will have 2 minus 10. The answer is negative 8. Then we will write mod 26. In our table here, there is no value for negative number. So we will convert this into equivalent mod value. So this negative 8 we add by 26. The answer is 18. Then mod 26 is here. The value or the answer here is 18. So for the number 2, the corresponding value is 18. This pattern we're going to use for the remaining numbers. The number 4 becomes 20, 1, 17, 1, 17, 14, 4, 23, 13, 13 is 3, 14 is 4, 1 becomes 17, 23 is 13, 24 is 14, 6 becomes 22. Then step 3, we translate back to letters to get the decrypted message. We will use the same alphanumeric table in here. So the 18 is S, 20 is U, 17 is R, 17 R, 4 is E, 13 is N, 3 is D, 4 is E, 17 is R, then space, 13 is N, 14 is O, 22 is W. So the message is surrender now. This is the final answer. Today we're going to study affine cipher. We can generalize shift cipher further to slightly enhance security. By using a function of the form f of p is equal to the quantity ap plus b, then mod 26, where a and b are integers such that f is a bijection. The function needs to be a bijection, otherwise we could not decrypt the cipher. The function f of p is equal to the quantity ap plus b, mod 26 is a bijection if and only if the GCD of a, 26 equals 1, meaning this a and 26 are relatively prime. Such a mapping is called an affine transformation, and the resulting cipher is called an affine cipher. How to find the decryption function? Let the encryption function be the f of p is equal to the quantity ap plus b, mod 26, where GCD of a, 26 equals 1. This is the affine transformation. Since GCD of a and 26 is equal to 1, a has an inverse modulo 26, say a bar. That is, a bar times a is congruent to 1 mod 26. Given our encryption function, now we let f of p equals c. So we can replace the c in here. So the new function becomes c is equal to the quantity ap plus b, then mod 26. For decryption, we know the value of c, and we have to express p in terms of c. For that, we have to solve the congruence c is congruent to ap plus b, mod 26. We can rewrite this congruence into like this. We interchange the c and the quantity ap plus b. So the left side will be the ap plus b is congruent to c, mod 26. Let us transpose this positive b on the right side. So we have ap is congruent to c minus b, mod 26. Next, we're going to multiply both sides of the congruence by the inverse, or a bar. A bar times ap is congruent to a bar times the quantity c minus b, mod 26. This a bar and a will cancel each other, or it becomes 1. So we have 1 times p. Then we can remove this number 1. So we have this p is congruent to a bar times c minus b and mod 26. With this congruence, we can translate it back into equation. So we have this p is equal to a bar times the quantity c minus b mod 26. This is now the decryption function. Note here that the c is the number associated with the encrypted cipher. Let us see example 1. Encrypt the message "Thank you" by affine transformation. F of p is equal to the quantity 15p plus 13 mod 26. For step 1, we translate each letter to the corresponding element of Z sub 26. Again, we have this alphanumeric table. The word "thank you" is here, and the corresponding numbers for each of the letters are 19 for T, 7 for H, 0 for A, 13 for N, 10 for K, 24 for Y, 14 for O, 20 for U. Step 2. Replace each of these numbers p by the function f of p is equal to the quantity 15p plus 13 mod 26. We can start with the number 19. So we will do like this: 15 times 19, then plus 13. Simplifying this using our calculator, the value is 298. Then we take mod 26. When we divide 298 by 26, the remainder is 12. So for the number 19, the equivalent is 12. So we write it here. We will use this pattern for the remaining numbers. So for 7, it becomes 14. For 0 is 13. 13 is 0. 10 becomes 7. 24 becomes 9. 14 becomes 15. 20 becomes 1. For step 3, we translate this back to letters to get the encrypted message using this alpha numeric table, meaning the number 12 corresponds to letter M, 14 is O, 13 is N, 0 is A, 7 is H, 9 is J, 15 is P, 1 is B. This is the final answer. Example 2. Decrypt the message MONAH space JPB by affine transformation. F of p is equal to the quantity 15p plus 13 mod 26. The step 1 here is to find the decryption function. Here is our function that we derived a while ago. So this is p is equal to a bar times the quantity c minus b, then mod 26. A bar here is the inverse of a modulo 26. Here the a is equal to 15 and b is 13. Since GCD of 15 and 26 is equal to 1, we can find the inverse of 15 modulo 26. So step 2, we're going to look for the a bar or the a inverse. We write here 15 times a inverse is congruent to 1 mod 26. So in here we're going to find for an integer a bar such that when multiplied by 15 and the product is divided by 26, the remainder must be 1. We can use trial and error. Let us use our calculator and look for that specific integer. So in this case, the A bar is equal to 7 because this 7 multiplied by 15 and the product is divided by 26. The remainder is 1. Step 3. Now we substitute the values of A bar and B to the decryption function. This is our function. So it becomes like this. P is equal to 7 times the quantity C minus 13 mod 26. Let us copy this new function on top here. Now let's go to step 4. Translate each letter to the corresponding element of Z sub 26. We're going to use our alphanumeric table. The message is given as this. Now, the corresponding numbers for each of the letters are here. 12 for M, 14 for O, 13 for N, 0 for A, 7 for H, 9 for J, 15 for P, 1 for B. Then step 5, replace each of these numbers. Let's begin with the first number, 12. So it becomes like this. 7 times the quantity 12 minus 13. So the answer is negative 7. Then we take the mod 26. Let us convert this negative 7 into its equivalent positive integer. So this 26 plus negative 7, we will get this 19. Then we write again mod 26. And the answer here is 19. Meaning, for number 12, the equivalent number is 19. So we write it here. We're going to use this pattern to the other numbers. So 14 becomes 7, 13 becomes 0, 0 becomes 13, 7 becomes 10, 9 becomes 24, 15 becomes 14, 1 becomes 20. Step 6, we translate this back to letters to get the decrypted message. So the letter corresponding to 19 is T. For 7 is H, 0 becomes A, 13 is N, 10 is K, 24 is Y, 14 is O, 20 is U. So the message is thank you. This is the final answer. I hope you learned something from this video. See you again next time.